In the last couple of chapters, we spent time talking about the history behind how scientists first came up with the idea of what an atom was and how it looked like. So if we think back to some of the things that we learned in chapter 2, the first model of an atom that anyone came up with was Dalton, and he called his the plum pudding model of the atom, which for modern students I think is probably a little more easily understood as the chocolate chip cookie model. If you remember when we talked about that, we said that the dough of the cookie was supposed to be similar to the protons, and the chocolate chips were the electrons, and they were just kind of stuck in various places among all of the positive material of the atom. And so that was the initial thought of what an atom looked like. As they did more experiments and as they learned more, Bohr came up with the idea that no, that model didn't work so well, and so he thought that the protons and the neutrons were in a nucleus in the center of the atom, and the electrons were probably orbiting around the outside, much like we think of a planetary model where the sun is in the middle and the planets are orbiting the sun. He viewed the atom as the same way. He said, okay, the protons and neutrons are in the middle and the electrons are orbiting around the outside. As the author of your textbook explains, the problem with that model is that it really only works for the hydrogen atom, and it didn't work for most of the other elements that exist. So as they did some more experiments, they started coming up with another model of the atom, and what we have now is called the quantum mechanical model of the atom, and it's the most modern one, and it's the one that, at least with the knowledge we currently have available, that we feel is probably accurate. In this model, the protons and the neutrons still make up the nucleus of the atom. The electrons are still around the outside, but the difference is that they're not in an orbit like you would think of a planet orbiting the sun. Instead, they're in what's called an orbital, and these orbitals, depending on what level of energy they're at, are going to be in several different shapes. The further away that you get from the atom, the higher the energy level that the electron is in. So if I look at the very first energy level of the atom, so the energy level is going to be, again, how close is it to the nucleus? So the very closest level, energy level to the nucleus, there's only one orbital that's available, and it's called an s orbital. And there's only one s orbital available. Now, an s orbital is shaped very much like a sphere. And what you have to realize about the s orbital, or any orbital for that matter, it does not mean that the electron is traveling simply around the outside of it, but you have to think of the orbital almost as a hollow ball. And so the electron is on the inside, and it's allowed to bounce around absolutely any place within the orbital that it pleases. This is where you're most likely going to be able to find the electron for the atom in the s orbital, in a shape that looks very much like a sphere or a ball. And you have to think of it as three-dimensional. A lot of times that when you're looking at the pictures in your book, they try to draw a picture of a sphere, but because it's a flat two-page picture, you sometimes forget that, okay, this is really three-dimensional like a ball. Okay? Now, when you get to the second energy level, so another layer out, so to speak, on the second energy level, you're going to have another s orbital, and there will just be one of them, but you're also going to have p orbitals. Now, I'm not sure why they call it a p orbital, but the shape of it is like a dumbbell, and the dumbbell that I have here isn't a real accurate representation of the shape, but it's the best dumbbell that I have to show you, so that's the one we're going to utilize today. There are actually 3 different p orbitals, and it all has to do with how they're oriented in space. When you guys draw graphs in algebra class, normally you use a graph that has an x-axis going across and a y-axis that goes up and down. And so your p orbitals, you're going to have one that lies this direction along the x-axis. You're going to have another one that lies this direction along the y-axis, but because we're in 3 dimensions, it's not flat. And so you're also going to have a z orbital that sticks out towards you. And so if you have a piece of paper, it's going to stick out from the paper and behind the paper towards you. So X going horizontally, Y going vertically, and Z going out this direction. Okay, so there are actually 3 p orbitals available at the second energy level. So that means at the first energy level, I only have 1 orbital available to put any electrons in. At the second energy level, I have 1 s orbital, the spherical shaped ones. I have 3 p orbitals, which are the dumbbell shaped ones. And so that gives me a total of 4 orbitals at the second energy level. And when I get up to the third energy level, and again, I just keep going out further and further and further from the nucleus of the atom. In the third energy level, I'm again going to have an s orbital. I'm going to have 3 p orbitals, just like I showed you before. The only difference is that as I go out, they're going to keep getting bigger. So an s orbital at the first energy level is going to be small. The second energy level is still going to look like a sphere, but it's going to be bigger. Third energy level, again, still a sphere, just that much bigger. And so the dumbbells at the third energy level are going to be larger than the dumbbells at the second energy level. Okay, so I'm going to have an s orbital, 3 p orbitals, and I'm going to add d orbitals. And there are pictures of those in your book. I'm not going to try to draw them or necessarily try to show you what they look like, but there are 5 d orbitals. So that's going to give you a total of 5 plus 3 plus 1, which would be a total of 9 orbitals at the third energy level. When I get to the fourth energy level, I still have an s orbital. I still have 3 p orbitals. Again, I'm going to have 5 d orbitals, and they come in varying shapes. Check your book for that. And when I get to the fourth energy level, I have f orbitals, and there are 7 of those. And so when I add, and there aren't even any pictures of those in your book, because as the more orbitals you get, the shape just gets increasingly complex. So when I get up to this energy level, 7 and 5 is 12, plus 3 is 15, plus 1 is 16. So there are 16 orbitals associated with the fourth energy level. If you go up to the fifth energy level, then you've got a g orbital, and I think the next one is an h orbital. We rarely talk about orbitals that high, and in fact, in this particular chemistry class, I'm not going to expect you to know how the electrons start going into the orbitals for anything up above a d orbital. We're going to talk about how electrons go into those orbitals the next time that we meet together over video. But I wanted to explain to you that for each particular energy level, the s orbital is lower in energy than the p, and it's lower in energy than the d. So as I go from s to p to d, this is lower energy, middle energy, highest energy. So they're going to increase in the amount of energy as I go across this way, but also as I go more energy levels out. Now, I don't want you to get too confused when we get into the next lesson, because how the electrons start filling these orbitals doesn't necessarily go in the same order. So I want you to kind of hold on to this loosely. These are at the third energy level, but we'll talk more about how the electrons actually fill the energy levels in the next lesson.